but an iron object struck the Earth. Such an event happened today, Phoenix would, I believe, be destroyed. You know, there have been reports of anomalous lights and even ball lightning associated with the apex of the pyramid. What does that mean? I don't know.
The Younger Dryas period, named after the Dryas octopetala flower which thrived in cold conditions and became common in Europe during this time, presents a fascinating chapter in Earth's history. This period, spanning approximately from 12,800 to 11,500 years ago, marks a transition from the late Pleistocene to the early Holocene. It's characterized by a dramatic downturn in temperature, disrupting the gradual warming trend following the last glacial maximum, the coldest phase of the last ice age. This abrupt shift led to a drop in temperatures estimated to be between 2 to 6 degrees Celsius in a relatively short time.
When the world went cold again during the Younger Dryas, the meltwater flowing from the glaciers into the oceans declined if it didn't stop altogether. And then about 1,300 years later, boom, it started up again. And that gave us meltwater pulse 1b.
The effects of the Younger Dryas were not just confined to the North Atlantic region, but were felt globally, with evidence of climatic changes found in Asia, South America, and even the Southern Hemisphere. The resulting cold and dry conditions had a significant impact on vegetation patterns, ecosystems, and human populations dependent on hunting and foraging. Adding to the intrigue of this period is the proposed comet impact hypothesis. This theory posits that a comet, or fragments of one, struck Earth or exploded in the atmosphere, potentially in multiple waves. The impact, likened to the energy release of several nuclear explosions, is thought to have triggered widespread wildfires, consuming vast areas of forests and grasslands. These fires likely contributed to the formation of the black mat layer, a carbon-rich deposit found at numerous Younger Dryas sites. Supporters of this hypothesis point to evidence such as microspherules and nanodiamonds, typically formed under high-impact conditions, and elevated levels of rare elements like iridium and platinum to bolster their claims.
The reason it's black is because it's so loaded with soot, which suggests wildfires perhaps on a global or at least a hemispheric scale that preceded the tremendous flooding that followed in its wake.
Charcoal and soot layers in geological records also align with this time frame, suggesting extensive burning. However, the hypothesis is not without its challenges and controversies. One major point of contention is the absence of a clear impact crater, typically expected from such an event. Proponents argue that the comet might have disintegrated in the atmosphere or struck an ice sheet, leaving no obvious crater. Additionally, critics propose alternative explanations for the climatic shift, such as changes in ocean circulation patterns or volcanic activity. The debate continues as the evidence for a comet impact, while compelling, is not universally accepted. The Younger Dryas impact hypothesis, which suggests a comet impact around 12,800 years ago, is a topic that really captures the imagination with its blend of geological mysteries and climatic upheaval. At the heart of this hypothesis is an array of geological evidence. For instance, nanodiamonds, these tiny diamonds formed under extreme pressure, have been found across North America, Europe, and parts of Asia in sediment layers dating back to the Younger Dryas period. Their presence in such widespread locations hints at a high-energy event on a global scale. Similarly intriguing are microspherules, small spherical particles often linked to extraterrestrial impacts or volcanic eruptions. The high concentrations of these particles found in the Younger Dryas boundary layers further point to a large impact event, but there's more. We see other materials like elevated levels of iridium, rare on Earth but common in meteorites, and magnetic grains containing iridium. Plus, the discovery of soot and carbon-rich layers in these same sediments suggests widespread burning, likely due to wildfires ignited by the impact.
Now, these shock-synthesized hexagonal diamonds only occur. There's no known natural process that will produce them, except for the intense heat and pressures of a cosmic impact. Evidence of impact material and the extinction of the megafauna 12,900 years ago. The impact material contains iron oxide spherules in a glassy iron silica matrix, which is one indicator of a possible meteorite impact.
Then there are the Carolina Bays, these elliptical depressions along the US Atlantic seaboard. Their origin is hotly debated, but some researchers think they might be craters from secondary impacts of comet fragments, aligning in a pattern that could suggest a comet coming from the northwest. The climatic impact of this proposed event is just as dramatic. Imagine a comet impact throwing massive amounts of dust, soot, and particulate matter into the atmosphere. This debris, spreading globally, would have blocked sunlight, leading to a sudden drop in temperatures. This is exactly what we see when we look at climate models and ice core data from Greenland and Antarctica, which show a sharp temperature decline coinciding with the time of the proposed impact. The cooling effect was particularly strong in the northern hemisphere, with temperature drops estimated between 3 to 11 degrees Celsius in some regions. And if that wasn't enough, the comet impact could have also disrupted major ocean currents, like the Atlantic meridional overturning circulation, leading to even further cooling, especially in the North Atlantic. During the transition from the Pleistocene epoch to the Holocene, which roughly overlaps with the Younger Dryas period, something dramatic happened in North America: the extinction of numerous large mammal species. This included some iconic megafauna like woolly mammoths, mastodons, saber-toothed cats, giant ground sloths, and even the North American camel and horse. These extinctions weren't evenly spread across regions, with North America being particularly hard hit. Now, the intriguing part is the timing of these extinctions, which coincides with the Younger Dryas period. This has led proponents of the Younger Dryas impact hypothesis to suggest a connection between the comet impact and these mass extinctions. They argue that the comet impact would have triggered a cascade of ecological disruptions, including wildfires, climate change, and disruptions in the food chain. These sudden environmental changes might have outpaced the ability of these large species to adapt, ultimately leading to their demise. However, it's important to note that there are opposing views. Some scientists argue for alternative explanations, such as the overkill hypothesis, which suggests that human overhunting played a significant role in these extinctions. Others propose natural climatic changes independent of any impact event as potential drivers.
Now, in these events that terminated the Ice Age, roughly half the great megafaunal species on Earth died out very rapidly. All of a sudden, around 12,000 to 13,000 years ago, a huge number of fossil remains were introduced into the environment. And then at the end of this, these species are extinct. They don't exist anymore. Like it says here, each square represents a fossil specimen of an extinct megafaunal species.
So the debate continues, and the impact hypothesis is just one of several competing theories. The Younger Dryas impact hypothesis doesn't stop at biological consequences. It also has implications for early human populations, particularly the Clovis culture. This culture, known for its distinctive stone tools, was widespread across North America during the same time frame as the Younger Dryas. Researchers have noticed a connection between the apparent disappearance or transformation of the Clovis culture and the onset of the Younger Dryas. This suggests that the proposed impact event might have significantly disrupted the way of life for these ancient people. The rapid shift to colder, drier conditions during the Younger Dryas would have undoubtedly affected the availability of food and resources for these hunter-gatherer populations. The changes in megafauna populations, which were a crucial resource for Clovis people, would have compounded these challenges. Archaeological evidence supports this idea of adaptation. There's a noticeable change in human tool technology and subsistence patterns after the Younger Dryas, reflecting a response to new environmental conditions and available resources. This period also marks the emergence of more regionally diverse cultures compared to the previously widespread Clovis technology. Carlson draws attention to rapid temperature changes in Earth's history, particularly emphasizing events like the Younger Dryas, a period marked by a sudden return to near-glacial conditions after a period of warming. His perspective challenges the conventional view of gradual climate shifts and instead suggests a dynamic and potentially unstable climate system. He points to historical precedents, such as the Bolling-Alerod warming period before the Younger Dryas, where rapid shifts in climate are evident in paleoclimatic records. These events have been studied to understand the sensitivity and resilience of the Earth's climate system. One of Carlson's intriguing hypotheses is the idea that comet and asteroid impacts may have played a more significant role in Earth's history than currently recognized. He speculates that these impacts could have triggered ice ages or abrupt climatic shifts, potentially even contributing to mass extinctions. In the context of the Younger Dryas, Carlson and other proponents of the impact hypothesis argue that a cosmic impact event was a primary trigger for the abrupt climate change observed during this period. They point to geological and ice core evidence to support their claims. Ice core records, particularly from Greenland and Antarctica, offer detailed insights into past climates. Carlson highlights layers in these cores that correspond to rapid changes in temperature and atmospheric composition, which he interprets as evidence for catastrophic events. Other geological markers, like sediment layers rich in iridium or elements linked to extraterrestrial materials, further support the impact hypothesis.
The presence of shock-synthesized hexagonal and other nanometer-sized diamonds in Younger Dryas boundary sediments in association with soot and other wildfire indicators is consistent with a cosmic impact event of 12.9 Ka.
Randall Carlson's theory proposes the existence of advanced human civilizations that thrived long before the commonly accepted timeline of known history, potentially even preceding the last ice age, which ended roughly 11,700 years ago. This challenges the conventional view that attributes the emergence of civilization to much later periods, such as the Sumerian and ancient Egyptian civilizations that arose around 6,000 years ago. According to Carlson, these prehistoric societies weren't just technologically advanced, they also possessed profound spiritual understanding and wisdom. He speculates that their technological capabilities could have included advanced architecture, astronomy, and other sciences, far surpassing what is typically associated with prehistoric cultures. To support his theory, Carlson points to the complexity and sophistication of ancient structures like the pyramids of Egypt, Stonehenge, and various megalithic sites worldwide. He argues that the precision in construction, astronomical alignments, and engineering skills evident in these structures suggest a higher level of knowledge and technological capability than mainstream archaeology typically acknowledges. Many of these ancient structures exhibit precise alignments with astronomical phenomena, such as solstices and equinoxes, which Carlson suggests is evidence of advanced astronomical knowledge. For instance, the layout of the Giza pyramid complex is aligned with the stars in the belt of the constellation Orion, while Stonehenge aligns with the solstices. One of Carlson's key ideas is that these advanced ancient civilizations might have met their downfall due to catastrophic events, like comet impacts or other natural disasters. These disasters could have wiped out significant populations, leading to the loss of knowledge and technology. He also posits that remnants of this lost knowledge can be found in mythologies, religious texts, and ancient symbols across different cultures. According to Carlson, these ancient stories and symbols may contain allegorical references to real events and the lost advanced knowledge of these prehistoric civilizations.
The archaeologists and the prehistorians, people are looking at that, have failed to take into account the severity of these events we're talking about. You don't realize the extent of the total remodeling of this planetary surface that took place. Because the question always is, where are the artifacts? Where's the pottery? Where is the evidence that this civilization existed?
Randall Carlson's theory about advanced ancient civilizations is truly fascinating and a bit of a departure from what we usually hear in mainstream archaeology. He's suggesting that highly sophisticated societies might have existed tens of thousands of years ago, way before the traditional cradles of civilization like Mesopotamia, Egypt, the Indus Valley, and China came into the picture. Imagine civilizations thriving before or even during the last ice age, which wrapped up around 11,700 years ago. That idea alone pushes back the conventional timeline of human development by several thousand years. Now, when you look at the evidence Carlson brings to the table, it's primarily centered around those massive and mystifying megalithic structures scattered across the globe. Take the pyramids of Giza, for example. Their alignment with the stars of Orion's belt and the precision of their construction is just mind-blowing. Or Stonehenge with its solstitial alignment standing there on the Salisbury Plain.
Two of these shafts go all the way through the body of the pyramid and exit on the outside and actually point at particularly significant stars.
These structures suggest that the people who built them had a far more advanced understanding of astronomy than we usually give them credit for. Carlson dives into the engineering and architectural skills of these ancient builders. He talks about how they constructed these massive stone structures, some involving stones weighing several tons. Just think about the logistics of transporting and precisely placing these enormous stones over great distances. It indicates a level of engineering know-how and physical physics that seems way ahead of their time. Now moving on. Randall Carlson's theory about ancient civilizations is absolutely something different, isn't it? He really makes you think about the roots of our history in a new way. Just consider the megalithic structures scattered all over the world.
When you account for the rise of sea level and the isostatic subsidence of the sea floor, it's not at all implausible that you had a large island complex in the mid-Atlantic Ocean.
Carlson sees these as evidence of advanced prehistoric civilizations. The Great Pyramid of Giza, for example, is made up of over 2 million stone blocks, each weighing tons, and they're all placed with incredible precision. It's not just about the sheer size, but the sophistication in their construction. And it's not just in one place. These megalithic structures are everywhere, from the stone circles in Europe to the pyramids in Egypt and Mesoamerica. Carlson points out that the similarities in construction techniques and astronomical alignments across different cultures hint at a possibly shared or globally distributed source of knowledge. It's like these ancient builders were all tapping into the same advanced understanding, which is pretty mind-blowing to think about. Now, where it gets even more intriguing, is how Carlson links the disappearance of this advanced knowledge to catastrophic events. He often refers to the younger Dryas impact hypothesis, suggesting that a comet impact might have triggered drastic climatic changes at the end of the Ice Age.
You may have periods of time where you have multiple impacts occurring over a short period of time associated with the destruction and disintegration of large comets.
Imagine massive flooding, climate shifts, and entire civilizations collapsing. It's like something out of a movie, but Carlson suggests it could be what wiped out these advanced societies and their knowledge. But here's the thing. He thinks this lost knowledge didn't just vanish. According to Carlson, it lived on in myths, legends, and religious texts, which he sees not just as stories but as historical records. Take the flood myths, for example, like Noah's Ark or the Epic of Gilgamesh. Carlson sees these as allegorical references to actual historical events, like massive post-glacial flooding. He believes that remnants of knowledge from these advanced civilizations were passed down through generations, albeit in a fragmented and symbolically encoded way. Moving back to megalithic structures, Randall Carlson's work on the astronomical alignments of megalithic structures is like peeling back layers of history to reveal the deep astronomical knowledge of ancient civilizations. Take the megalithic temples of Malta, Hagar Kim, and Manajra, for instance. These structures aren't just old, they're among the oldest freestanding structures in the world, dating back to around 3,200 BC. What's really remarkable about them is how they demonstrate an intricate understanding of celestial movements, particularly the solar cycle. When you look at these temples, especially during the equinoxes, it's like watching a celestial dance choreographed by ancient architects. At Manajra on the equinoxes, the sunlight filters through a specific aperture, illuminating an inner stone slab. It's this incredible precision that highlights how the builders weren't just stacking stones, they were aligning them with celestial events, marking the change of seasons with architectural precision. But it's not just about alignments. The architectural design itself is a marvel.
Some reference to such an event can be traced in many of the legends and myths surrounding these stars that have come down to us from nations far removed from each other.
The layout of the temples seems carefully planned to align with the sun's position at significant times of the year. For example, the main axis of Hagar Chim is almost perfectly oriented to where the sun rises during the solstices. It shows a level of planning and understanding of the sun's movements. And then there's the construction itself. We're talking about huge megaliths, each weighing several tons, placed with such accuracy that they align with celestial events. It wasn't just a matter of brute force, it required sophisticated knowledge of astronomy and construction techniques. Plus, they used local limestone, which is abundant in Malta. The complexity of these temples goes beyond just their size or the weight of the stones. They have multiple apses, altars and intricate carvings, all forming part of a complex architectural design. The series of semicircular chambers connected by a central corridor, and their alignment with specific astronomical events. The pyramids of Giza, especially the Great Pyramid, the precision with which these pyramids align to the cardinal points of the compass is just mind-boggling. Think about it. The Great Pyramid, built for Pharaoh Khufu around 2580–2560 BC, is aligned almost perfectly north, south, east, and west. The northern side aligns to within a fraction of a degree of true north. Considering the era it was built in, that's an incredible feat of geometry and astronomy. The construction techniques themselves are a mystery. The ancient Egyptians might have used stars or the sun's path to find true north, which implies they had advanced surveying techniques and a deep understanding of angles and straight lines. It's impressive when you consider the tools and technology available at the time. Then there's the fascinating Orion correlation theory. This theory suggests that the layout of the three main pyramids at Giza mirrors the stars in Orion's belt. Proponents like Robert Bauval believe this alignment was intentional, reflecting a belief in the connection between the heavens and the afterlife.
They speak of these two regions of the sky, the southern sky with the stars of Orion, and can we move one slide up? Here's a nice view of them. They're pristine, by the way. It's really eerie how they carve those texts by hand, and some of the details is extraordinary.
With Orion associated with Osiris, the god of rebirth and the afterlife, the pyramids in this view were not just tombs but also celestial maps and gateways for the pharaoh's soul to the afterlife. The smallest pyramid, Menkaura's pyramid, is slightly offset, mirroring the offset of the smallest star, Mintaka, in Orion's belt, which adds another layer of intrigue to this theory. The design of the pyramids also incorporates alignments with the sun and specific stars and constellations. For example, certain shafts within the Great Pyramid align with particular stars. These could have been more than architectural features. They might have held spiritual significance, possibly serving as pathways for the pharaoh's soul to the stars. Also, on specific days of the year, the sun sets between the pyramids, creating a visual spectacle likely significant in ancient Egyptian ceremonies. Now one of the most known megalithic structures.
Would it be fair to say that there's an element of a rediscovery of a
Yes.
lost technology from the past?
I think it would be fair to say that, yes.
Stonehenge, out there on the Salisbury Plain in Wiltshire, England. What's particularly fascinating about Stonehenge is its astronomical alignment and how it was constructed. The way it lines up with the summer solstice is probably what it's most famous for. On the longest day of the year, the sun rises right over the heel stone, which is set just outside the main stone circle. As the sun comes up, its rays shoot straight through the entrance and light up the center of the circle. Stonehenge also aligns with the winter solstice and possibly other celestial events. During the winter solstice, the sunset is framed by those massive stone trilithons, and some experts think it might even line up with lunar phenomena, which just adds another layer to how the builders understood both the sun and the moon's movements. When you think about how Stonehenge was built, it's even more mind-blowing. The final form was completed around 2500 BC, but it was built in phases over about 1,500 years. The main part of the monument is made up of these huge sarsen stones arranged in a circle, and there are smaller blue stones that were brought over from Wales. That's over 150 miles away. And then there's the layout of the stones. They're set up in this specific geometric pattern with an outer circle, an inner horseshoe arrangement, and those trilithon structures. The precision in the layout and how the stones are oriented show a really deep understanding of geometry and astronomy. It's not just a bunch of rocks placed randomly. Everything at Stonehenge is set up with purpose and meaning, which makes you wonder a little bit, doesn't it?